Hi everyone, I am Asit Dwivedi, Assistant Professor from BCA Department, IIMT College of Management, Greater Noida. Today, I am going to take one session about object-oriented programming using C++. Okay, first of all, we should know what is object-oriented programming. What is object-oriented programming? Object-oriented programming, in short, this is also called OOP, is a computer programming model that organizes software design around data or objects rather than functions and logic. An object can be defined as a data field that has unique attributes and behavior. OOP focuses on the objects that developers want to manipulate rather than the logic required to manipulate them. This approach to programming is well suited for programs that are large, complex, and actively updated or maintained. This includes programs for manufacturing and design as well as mobile applications. For example, OOP can be used for manufacturing system simulation software. Now, I'm going to discuss what is the benefits of OOP. What is the advantages or benefit of using OOP? First one is modularity. Modularity encapsulation enables objects to be self-contained, making troubleshooting and collaborative development easier. Next is reusability. Code can be reused through inheritance, meaning a team does not have to write the same code multiple times or again and again. Productivity. Programmers can construct new programs quicker through the use of multiple libraries and reusable code. Now, next is easily upgradable and scalable. Programmers can implement system functionalities independently. Now, next is interface descriptions. Descriptions of external systems are simple due to message passing techniques that are used for objects communication. Next is security. Using encapsulation and abstraction, complex code is hidden. Software maintenance is easier and internet protocols are protected. Flexibility. In flexibility, polymorphism enables a single function to adapt to the class it is placed in. Different objects can also pass through the same interface. Now, structure of object-oriented programming. The structure or building blocks of object-oriented programming include the following. First one is classes. Classes are user-defined data types that act as the blueprint for individual objects, attributes, and methods. Next, objects. Objects are instances of a class created with specifically defined data, objects can correspond to real-world objects or an abstract entity. When class is defined initially, the description is the only object that is defined. In the structure, next is methods. Methods are functions. What are methods? Methods are functions that are defined inside a class that describe the behaviors of an object. Each method contained in class definitions starts with a reference to an instance object. Additionally, the subroutines contained in an object are called instance methods. Programmers use methods for reusability or keeping functionality encapsulated inside one object at a time. Now next is attributes. Attributes are defined in the class template and represent the state of an object. Objects will have data stored in the attribute fields. Class attributes belong to the class itself. Now there are OOPS concepts. The OOPS concepts include the following. First one is object, class, inheritance, polymorphism, abstraction, encapsulation. Okay. This is the diagrammatic representation of the OOPS concepts: class, object, abstraction, encapsulation, polymorphism, inheritance. Now, I'm repeating this one. Object, what is object? An object is a real world entity that has attributes, behavior, and properties. It is referred to as an instance of the class. It contains member functions, variables that we have defined in the class. It occupies space in the memory. Different objects have different state or attributes and behaviors. Now, class. What is class? A class is a blueprint or template of an object. It is a user-defined data type. Inside a class, we define variables, constants, member functions, and other functionality. It binds data and functions together in a single unit. It does not consume memory at runtime. Note that classes are not considered as a data structure. It is a logical entity. It is the best example of data binding. Note that a class can exist without an object, but vice versa is not possible. Class is possible without object. Okay, but object without class is not possible. The following figure best illustrates the class and object in OOP. Our class is first rectangular box. Class is car. Properties, methods. Now defining two objects, of this class. First object, uh, for object for in class there is car, creating object Audi. Second object, BMW. Properties, methods of Audi, properties, methods of BMW. Inheritance. What is inheritance? The concept allows us to inherit or acquire the properties of an existing class. This class is also known as parent class into a newly created class, child class. Okay, derived class will be child class. It is known as inheritance. It provides code reusability. This is the diagram for inheritance. First one, there is person. A person can be employee or customer. Okay, so employee is also a person, customer is also a person. Okay, so employee is inheriting properties from person, and customer can also inherit properties from person. Okay, now in employee, their employee may be manager or developer. Okay, so manager will inherit properties from employee. Okay, then from person. So manager will get properties of employee and person both. Okay, similarly, developer. Developer is inheriting property from employee, and employee is inheriting properties from person. Okay, so developer will get properties of uh, employee and person both. Now next is polymorphism. The word polymorphism is derived from the two words, that is poly and morphs. Poly means many and morphs means forms, means many forms. It allows us to create methods with the same name but different method signatures. It allows the developer to create clean, sensible, readable, and resilient code. And this is the example of diagrammatic representation of polymorphism. The figure given below best describes the concepts of polymorphism. A person play an employee role in the office, father and husband role in the home. So person can be employee, person can be father, person can be husband. Okay. Now next is abstraction. The concept allows us to hide the implementation from the user but shows only essential information to the user. Using the concept, developer can easily make changes and add it over time. This is the diagrammatic representation of an abstraction. My test, there is addition, subtraction, multiplication. There are following advantages of abstraction. It reduces complexity. It avoids delicacy, eases the burden of maintenance, increase security and confidentially. Now, next concept is encapsulation. Encapsulation is a mechanism that allows us to bind data and functions of a class into an entity. It protects data and functions from outside interference and misuse. Therefore, it also provides security. A class is the best example of encapsulation. This is the diagrammatic representation of class. Class, opening bracket of class, closing braces of class, in between data members, where we will define variables, then methods or functions. Now, limitations of OOP, object-oriented programming, requires intensive testing processes. Solving problems takes more time as compared to the procedure-oriented programming. The size of the programs created using this approach may become larger than the programs written using the procedure-oriented programming approach. Software developed using this approach requires a substantial amount of pre-work and planning. OOP code is difficult to understand if you do not have the corresponding class documentation. In certain scenarios, these programs can consume a large amount of memory, not suitable for small problems. Takes more time to solve problems. Now, list of object-oriented programming languages. Now, there are various object-oriented programming languages. The top 20 OOP languages are Java, C++, C Sharp, Python, R, PHP, Visual Basic .NET, JavaScript, Ruby, Perl, Object Pascal, Objective-C, Dart, Swift, Scala, Kotlin, Common Lisp, MATLAB, and Smalltalk. Applications of OOPs. Computer graphics applications, object-oriented database, user interface design such as Windows, real-time systems, simulation and modeling, client-server system, artificial intelligence system, CAD, CAM, software, office automation system. These are the areas where OOP can be used. Now, next topic I am going to discuss in C++, token in C++. Now, question is what is token? A C++ program is composed of tokens which are the smallest individual unit. Tokens can be one of several things, including keywords, identifiers, constants, operators, or punctuation marks. Tokens in Token in C++, there are 6 types of tokens in C++: keyword, identifiers, constants, strings, special symbols, operators. Now I will discuss them one by one. First one, keywords. What are keywords? In C++, keywords are reserved words that have a specific meaning in the language and cannot be used as identifiers. Keywords are an essential part of the C++ language and are used to perform specific tasks or operations. Now, next one is identifiers. What are identifiers? In C++, an identifier is a name given to a variable, function, or another object in the code. Identifiers are used to refer to these entities in the program, and they can consist of letters, digits, and underscores. However, some rules must be followed when choosing an identifier. Now, the rules are: the first character must be a letter or an underscore. Identifiers cannot be the same as keyword. Identifiers cannot contain any spaces or special characters except for the underscore. Identifiers are case sensitive, meaning that a variable name my variable is different from a variable name named my variable. See, here V is capital, here V is small. These are different in C++. Here are some examples of valid and invalid identifiers in C++. Valid, my underscore variable. It's valid. Student underscore. This one is valid as per rules. Invalid, my, then space variable. Contains a space. This is invalid. Student hash contains a special character, so this is invalid. Int is a keyword, so this is also not allowed. Now next is constants. In C++, a constant is a value that cannot be changed during the execution of the program. Constants often represent fixed values used frequently in the code, such as the value of pi or the maximum size of an array. To define a constant in C++, you use the const keyword followed by the data type and the constant's name, and then initialize it with a value. The value of the constant cannot be changed once it has been defined. Now here is an example. Const double. Const is for constant, double is data type, pi equal to 3.14159. Now string. What is string? In C++, a string is a sequence of characters that represent text. Strings are commonly used in C++ programs to store and manipulate text data. To use strings in C++, we must include the string header file at the beginning of our program. This will provide access to the string class, which is used to create and manipulate strings in C++. Now, special symbols. In C++, several special symbols are used for various purposes. The ampersand sign, this one, is used to represent the address of a variable, while the tilde is used to represent the bitwise NOT operator. Some of the most common special symbols include the asterisk used as the multiplication and pointer operators. Now, operators in C++, operators are special symbols that are used to perform operations on one or more operands. An operand is a value on which an operator acts. C++ has a wide range of operators, including arithmetic operators, relational operators, logical operators, and others. Now, first one, arithmetic operators. Arithmetic operators are used to perform mathematical operations such as addition, subtraction, multiplication, and division. Some examples of arithmetic operators include plus sign used for addition, minus sign used for subtraction, asterisk used for multiplication, and slash used for division. Now, next operator, relational operators, are used to compare two values and determine their relationship. Some examples of relational operators include double equal to sign used to check for equality, not equal to used to check inequality, greater than sign used to check if a value is greater than another, and less than sign used to check if a value is less than another. Now, next operators, logical operators. Logical operators are used to combine two or more relational expressions and determine their logical relationship. Some examples of logical operators include double ampersand sign used for the logical AND operation. This sign used for the logical OR operation, and exclamation sign used for the logical NOT operation. Now, constructor and destructor in C++. Now, constructor in C++, a constructor is a special member function of a class that and shares the same name as of class, which means the constructor and class have the same name. Constructor is called by the compiler whenever the object of the class is created. It allocates the memory to the object and initializes class data members by default values or values passed by the user while creating an object. Constructors don't have any return time because their work is to just create and initialize an object. This is the syntax for constructor. Class, class name. This is the class name. Private data members will come. In public, we are declaring constructor. This name C. Sorry. This class name, and this class name will be same. This is the name of the constructor, which will be same as class name. Then opening of constructor, closing of constructor, and this is the closing of class. Now, destructor in C++. Destructor is just the opposite function of the constructor. A destructor is called by the compiler when the object is destroyed, and its main function is to deallocate the memory of the object. The object may be destroyed when the program ends, or local objects of the function get out of scope when the function ends, or in any other case. Destructor has the same name as of the class with prefix tilde operator, and it cannot be overloaded as the constructor. Constructor take sorry Destructors take no argument and have no return type and return value. This is the syntax for destructor. Class, class name, private data members will come. Then public, declaring destructor. See, this name, this class name, and this class name will be seen for destructor. And this is the tilde sign. Tilde sign tells this one is destructor. Then opening of destructor, destructor body will come over here. Then this one is closing of destructor, and this is the end of the class. Thank you.